with one. Let's grab, everybody grab this rectangular, dark, shiny piece of flakiness.
It's like paper.
So look at, I'm going to place it up, well, I'd like to.
Oh, that's just
Power helps, right? Okay, here we go. So I'm going to refer back to this,
key,
this handout,
key.
the key that you have. I'm going to circle these circles that give me the characteristics of minerals. This is what I'm looking for. Minerals occur naturally. They are always solids. They have a crystal form and basic shapes. They have a definite chemical composition, and they are inorganic.
Are you all
Okay.
watching the modeling?
My first sample is this one. This is natural, this is the way we found it. This is the way it came. It was not cut like this.
It wasn't cut.
It was not, nope, it was not. So this one did, I mean, all of these occurred naturally because you have no way of, this is not manufactured. So yes, it was natural. Is this a solid? Yes. Does this have a crystal form and basic shape? Yes, it does. Does it, it's all the same. It does have a definite chemical composition, and it is inorganic. Is this a mineral?
Yes.
So this is what you will write into table 1.2. Use the characteristics of the mineral to determine if it is a mineral.
Is that what you gave all of us? Because that doesn't look like yours.
What?
Well, this one went to the different.
Yeah, it
This
does.
ours is.
Oh, that
you got like
thing.
a lens.
No,
or
you got like
something.
Hers is secret.
Oh, it's really.
Ours is
Oh,
like
the
black.
layer
came off of
Yeah, you probably got a thinner layer.
Don't talk to us.
That's a slide for the microscope.
You can peel the layers
It's a
off.
dye slide.
There does look like a piece of it.
Yours is not a mineral.
It's man-made.
Okay, now let's look at the second one. Let's pick up this, this multicolored piece.
No, man, this is a different one. Try it.
This one.
They can insert all of them.
Can you see that? Do y'all have a piece that looks like this? Okay, first, did this occur naturally? Yes. Is it a solid?
Yes.
Does it have a definite crystal form and basic shape?
No.
No, look at that. There's several things in here, right? So, what do we do?
It's not.
It is not a mineral.
Is this a mineral?
No, because it doesn't meet that one
Criteria.
characteristic or criteria.
But wait, our goal is not just to determine if it's a mineral, but look at your chart. Is it a rock too, right? So we could look at these individual pieces. I don't know if y'all can, that doesn't work. So within this rock, I see different things. What do you observe in here?
To me, it seems like there's quickly guessing about 3 different types of things in it.
Okay, what do we call these types of things that are in it? Okay, so let's look at each one individually then. There's several different things in here. Do they all meet these criteria? Are they inorganic?
They appear to.
Okay?
Yes.
Do they have definite chemical compositions, which you
Yes.
can't look at on the atomic level, I guess? They have different crystal shapes, okay? They're all solids. So what is this that I'm holding? Well, I'm not asking for the name, but we don't know that. It's a rock that is composed up of different minerals. So we're doing two things in this chart, really. We're looking to see, are these minerals, and is this one mineral, or is it a rock composed of multiple minerals? I'm sorry, that was confusing.
Well, when you have a specimen like this, how can you differentiate that it's organic or inorganic?
If you find it out in the pasture, it's naturally occurring, somebody didn't go put it out there, and usually, if it's a rock, it's inorganic. If you find, fossils and stuff like that in it, those pieces are organic, but the minerals that form around it are inorganic.
Let me ask you a question then. For a fossilization to occur, doesn't that material absorb the minerals from around it?
Sometimes there's a mineral replacement, and that mineral forms in the shape of the formerly organic material.
Slide, Amber.
Okay, the third piece, guys. This is Quentin's pink again. Okay, first of all, do you see the shiny faces? Okay, so what is this?
It looks like it's all one chemical composition.
But it has white stuff in it. Like it almost looks marbled.
Okay,
That's my question. I mean,
well look, on mine, if you look at one broken end, it is a flat piece. And so you can see that even though the colors might vary within it, it's still one substance. So this is a mineral. So this is what we're going to look at today, is characteristics of minerals, because there's a lot of characteristics that we look at to tell the differences between minerals. And color, as you brought up just now, color is the least reliable of any of these characteristics. So for example, we're going to look at your next tray, the tray with the straws in it. So just swap your trays. You have two specimens in your tray that look very similar. Now these two samples look very similar. I want you to lay both of these samples over some kind of text on your paper. Now look through your samples at your text. Not just on white paper, but I want you to be able to look through at the words on your paper. Also, while you're doing it, rotate your samples. Now these are, guys, listen, your samples are, they're crystalline shapes and they have definite sides. So try rotating them 90 degrees up vertically and see how that affects your visibility through the sample. Yeah, that's true, but that's not Okay, I want you to note some observations. What do you notice about these samples? How are these samples similar and how are they different? So very quickly, I want you to talk with your face partner. How what are the similarities and differences in these samples? And you have 30 seconds to have this discussion.
Are you gonna
Okay. What are some similarities, Mary Lou? Listen, Mary Lou says that both of them are transparent.
You wouldn't call that transparent.
Brandon, did you see any other similarities?
See through them, same thing, they're clear. They both are clear.
Okay. Okay. Ashley?
You can see through both of them, but we thought that one is more transparent while the other one is translucent.
Okay, good words. Now, did you do this? Here's one sample. Did you rotate it and look through it at all the different angles through the crystal? Okay. Did one of the samples look the same through all the different viewing angles? While the other one, you can see through it one way, but the other way you cannot. Okay, it's sort of like this. Take your straws. One person grab the straws in your hand. Put it up to your face and look through the straws. This is a handful of straws. You can see through the straws one way. Now rotate them 90 degrees. Can you see through the straws this way? It's still a handful of straws. It depends on the angle that you view it from as to whether the light can penetrate the straws. This is very similar to this second sample. What is it called? So the image on the sheet of paper is transmitted through the crystal. The second sample is called TV stone because you can see through it one way and you can't see through it another way. It's called ulexite, and it's an evaporative mineral, meaning that there's these chemicals and the water evaporates out and leaves this mineral behind. This crystal forms from evaporation of the water. So do you see how you can view through it one way and
Yeah, one serves like a magnifying glass.
See through it that way, but not the
It
other
blows it up.
Yes.
You can see it clearly.
side.
right. So it's the way the light reflects through there that changes it. Okay, so you see, we've observed the optical property of these two minerals to distinguish between the two of them. Because if you were just to pick them up and look at them, you might say, okay, they look the same. But there's this major property that is different that can distinguish the two. Ready? We're going to move on and we're going to look at more properties of these samples. So there's one view. Okay. Turn to your mineral field test summary. And we're going to go through the properties that we're going to look at with these minerals. We're going to take a break, and then you are going to test the properties of some minerals. Okay, you got your table? So this is what you're going to refer to. All right, you are going to get a tray, materials managers. Your tray is going to have an egg carton, 12 minerals. Please listen. You can walk, but listen. A mineral test kit, a file, and a streak plate. Now, there's also a streak plate in the test kit. But we're not going to use that today because y'all are going to receive these kits and we didn't want to dirty up your test plate. So use the one that's loose. Yes, and just for cleaning's sake, y'all can bring back the trays.